Now that we have a rough idea about the code execution and logic synthesis, let's have a look at the syntax and conventions of Verilog. So first, we have the Verilog documentation. It is nothing but writing comments within your code. Documentation can be single line or multi-line. The conventions for writing both are shown here in this piece. Now, white space. Please keep in mind that the white space characters are ignored by the Verilog compiler, but they can be used time to time within codes to increase readability of your code. Number specification. Verilog will encounter both sized and unsized numbers. The sized number format starts with the specification of size, followed by base format and the number itself. Verilog supports four base formats, which are decimal, binary, hexadecimal, and octal. However, if the number is missing the base format specification, Verilog compiler will treat it as decimal number. The left column of this table shows a few examples of sized number representations. The right column, however, shows the examples of unsized number representations. You can see here that unsized numbers do not come with a proper size specification. Although the size is machine specific, but it should be at least 32 bits. Now that we have an idea of number representation, let's invest some time on the Verilog variables. A variable in Verilog can be assigned one of these values, which are 0, that stands for false or 0 logic level. 1 represents true or logic 1. However, a variable can also be at undefined and high impedance states, which are denoted by X and Z respectively. We will observe the applications of these states gradually in this. So the Verilog variables can be of two types, which are nets and registers. The net data type can be interpreted as the interconnects found in the actual hardware. Nets are declared with the keyword where. And another type of variable is the register type variable. They are declared with the keyword reg. Both reg and wire declarations in Verilog are shown here. Vectors. By default, reg and wire type variables are single bit. However, if they are associated with bit field indices, they are treated as multi-bit variables or vectors. This code block, you can see 8-bit wire type and 32-bit register type variable declarations. This line shows how individual bits of multi-bit vector can be accessed in Verilog. Verilog also supports memory type variables. Memory type variable in Verilog has the same structure of an array in C. This code shows how a one-dimensional memory block can be initialized in Verilog. Here, mem is an array of 16 elements, with each element being 8 bits wide. You can also initialize two-dimensional memory blocks. This code defines mem to be a 2D array with 16 elements in x directions as before. This time it also contains 8 elements in y direction as well. So we are defining a 2D array of 128 elements. Again, each element is 8-bit wide or a vector of 8 bits. Parameters or constants can also be declared in Verilog alongside variables. Here we can observe a parameter declaration in Verilog. So far, we have been introduced with the concepts of modules, variables, and constants. These elements are collectively known as Verilog identifiers. The identifier names must follow some restrictions, which are an identifier name must not begin with a digit and it should not be a reserved Verilog keyword. Please also keep in mind that Verilog is case sensitive. From this table, you can easily differentiate the valid identifier names from the invalid ones.